All right, let's get right into it. Today, we're going to unpack a huge question in the world of AI. How do you take a tool that millions of developers rely on, something like GitHub Copilot, and make it better without accidentally making it worse? So this is the core problem, right? You've got this amazing, powerful AI, and of course, you want to keep improving it. But every single change, every little tweak, comes with the risk of what's called a regression. That's just a fancy developer term for when a new update breaks something that used to work just fine. It's a really high-stakes balancing act between pushing forward and not messing things up.
And this is what makes it so tricky. This insight from GitHub's own engineering team really says it all. See, an AI isn't like regular software where you can pretty much predict what a code change will do. Here, just changing the description of a tool for the model can completely alter its behavior. A slightly different word choice could be the difference between a perfect answer and, well, a total dud. This incredible sensitivity is exactly why having a super rigorous, data-driven testing system is absolutely essential.
Okay, so how did GitHub even begin to solve this puzzle? Well, it all starts with this foundational idea they came up with called the Model Context Protocol, or MCP for short.
Honestly, the easiest way to wrap your head around MCP is to just forget all the technical jargon and think of it like a universal plug adapter, the kind you use when you travel. It creates one standard way for the AI model, like Copilot, to plug into and use all sorts of external tools and data, like the GitHub API. As long as both the AI and the tool speak MCP, they just work together, no problem.
So what does this actually look like in action? Well, you can think of it like a quick 5-step dance. First, the server basically says, hey, here are all the cool tools I have available. Then the agent, which is Copilot, grabs that menu of tools. Then you, the user, type in a request, like merge this pull request. The AI looks at its menu, figures out the best tool for that job, and what info it needs. And finally, the agent makes the call to that tool and hands the result back to the AI.
Now you have to get MCP, because it's the thing that makes their whole testing strategy possible. It lets them build what they call an offline evaluation pipeline. And this is the real secret sauce. It's a safe, totally controlled sandbox where they can test any and all changes to the AI before a single user ever sees them.
This pipeline is pretty neat, and it breaks down into 3 main stages. First up is fulfillment. This is where they basically throw a ton of test problems or benchmarks at the AI and just sit back and record everything it does. Then comes evaluation. Here, they take all those raw results, crunch the numbers, and actually score the AI's performance. And finally, summarization, where all that complicated data gets boiled down into a simple report card that tells engineers, yep, this new version is better, or nope, back to the drawing board.
Okay, that's a lot of theory. Let's look at a real-world example of one of these benchmarks. This is a perfect one. It's not some abstract puzzle, it's a real command the developer would actually type into their computer. Think of it as a question on the AI's big exam.
And here's the answer key. The system knows that for that command, the AI should have picked the merge pull request tool and filled in these arguments exactly like this. The AI's job is to make that translation from plain English to this precise code perfectly.
And of course, they don't just test one little thing. No, they have a whole library of these benchmarks that cover all sorts of different tasks. Here's another one, asking the AI to summarize comments from a completely different project. And again, look at this. This is the exact, super precise action the AI is supposed to take. It's pretty amazing when you think about it. It has to correctly identify the tool, the owner, the repo, and the discussion number, all from that one simple sentence.
Okay, so we've got the test questions and we've got the answer key. But how do you actually grade the AI? How do you take thousands of these individual results and boil them down to a clear, simple score that tells you if you're on the right track? Well, GitHub's report card for the AI is basically split into 2 big sections. First, did the AI pick the right tool for the job? And second, once it picked a tool, did it actually use it correctly? Did it feed in the right information? It's not enough to get one of these right. A passing grade means you have to ace both.
So how do they grade the tool selection part? It's a little more sophisticated than just a simple accuracy score. They focus on 2 key things, precision and recall. Here's an easy way to think about it. Precision asks, when the AI decided to use a specific tool, was it actually the right time to use it? This stops the AI from just overusing its favorite tool for every single problem. And recall asks, of all the times the AI should have used a tool, did it remember to? This stops it from just forgetting about a useful tool it has. The F1 score just kind of balances those 2 things into one handy number.
Now, to really play detective and figure out why the AI is making mistakes, engineers use this awesome tool called a confusion matrix. It shows them exactly when the AI gets confused between 2 similar-sounding tools. In this example, you can see that when the AI was supposed to use search_issues, it got it right 7 times, but 3 times it got confused and used the similar list_issues tool instead. This gives engineers a laser-focused view of exactly what they need to fix.
And that little mix-up, it has a real impact on the score. Because the AI mistakenly used the list issues tool when it shouldn't have, the precision score for that tool drops to 0.77. Now, this number isn't just some abstract grade, it's a direct signal to the developers that tells them, hey, the AI is overusing this tool. We need to go back and tweak its description to make things clearer.
All right, section 2 of the report card, argument correctness. This is where they run through a checklist. Did the model just make stuff up, inventing parameters that don't even exist? Did it provide all the arguments it was supposed to? And this is a big one. Did it include all the arguments that are required for the tool to even work? And finally, were the values it provided a perfect exact match?
So when you put it all together, you've got the MCP framework, this huge library of tests, and this super detailed grading system. What you end up with is a really powerful machine for making AI better, safely, and systematically.
And really, this quote from the team just says it all perfectly. The whole point of this entire pipeline is to get away from just feelings like, yeah, I don't know, it seems a little better. This system turns those vague feelings into hard data, measurable progress, and it points directly to the fixes needed when something goes wrong.
But, the work is never really done, right? The team is always adding more and more benchmarks to make the tests stronger, figuring out new ways to test really complex commands that use multiple tools, and constantly tweaking those tool descriptions. And it's all for one big goal, making the AI a better, more predictable partner for the developers who rely on it every single day.
And that really leaves us with one big question to think about. As these AI systems get woven more and more into our lives, handling tasks that are way more complex than just merging code, how important is it going to be that we have a reliable report card for them? Because in the end, if we're going to trust these systems, we have to be able to measure what matters.